Okay, hi students. So today I'm going to discuss with you regarding the EMF method of calculating the voltage regulation of synchronous generator. Right. So it is a recorded video. So whenever you have doubts, you can listen to me. You can listen to this video. You will be able to understand how the voltage regulation can be calculated using EMF method. Right. So first let me start with the problem. It is a sample problem. So a three-phase star connected 1.1 MVA 2.2 kV 50 Hz synchronous generator gave the following test data during OC and SC test. There is field current, open circuit voltage, and short circuit current. Everything it is given, right? They asked us to calculate what is the voltage regulation at zero point 0.8 power factor lagging by synchronous impedance method and ampere turns method. Synchronous impedance method means it is another name of EMF method. Okay, so now let me start doing this problem. So definitely at the end of the session, you will be able to calculate the voltage regulation of a synchronous generator by your own, right? Okay, so we usually will start the problem with given data to find everything, right? So the given data here is, so let me write the given data. So what it is given, so is 1.1 MVA. That means your power rating, right? So the power rating, it is given, which is equal to 1.1 MVA. So it is megavolt ampere. So MEA, so 1.1 into 10 to the power 6 VA. Then what else given? The line voltage of the machine, it is given 2.2 into 10 to the power 3 volts. Then the frequency value it is given. Armature resistance, we have armature effective resistance RA, it is given, which is equal to 0.22 ohm, right? They asked us to calculate to find what we are our objective. What we need to calculate here, it is voltage regulation. Voltage regulation, that is our objective. It is an important topic. So without knowing this voltage regulation topic, we cannot uh, do any further problem in our electrical machines to laboratory, right? So in laboratory also we are calculating voltage regulation by various methods. So one of the method is EMF method. Okay, so this is a test data is given, open circuit test data and short circuit test data it is given. See here, field current 10 amps, the corresponding voltage is 0.88 kilovolt. So here you have to convert into volt, that means into 10 to the power 3. Then for 20 volt 1.65 kilovolt, then 30 amps or 2.2 kilovolt, 40 amps 2.5 kilovolt, 50 amps 2.86 kilovolt, right? Now what our objective, primary objective is, this all the value it is given in line value. First we need to convert into phase value. You see here in this same thing I am going to do, since it is a star connection. So phase EMF value I am going to calculate. So 0.88 into 10 to the power 3 divided by root 3, right? So we usually, if you want to, for a star connection, if you want to calculate phase value, so we all know that V phase, which is equal to VL by root 3. So 0. So 0.88 into 10 to the power 3 divided by root 3. What you will get here, it is 508 volt. So for the 10 amps, your value is 508 volts. Then for 20 amps, the same procedure we need to follow, 953 volts. For 30 amps, you will get 1270 volts. This is a primary first step. We should convert the line value into phase value. Then afterwards we can draw the graph, right? Then for 40 amps, it is 1492 volts. For 50 amps, it is 1651. So this is a way how we are calculating the phase value from the given line value. Okay. So now let us start drawing our graph. So it is a graphical method, EMF method, MF method and all. From the graph only, we will be able to calculate the voltage regulation. So now let us start drawing the graph. Okay, so it is opening, wait. Okay, this is our graph. Okay, so we have one x-axis, we have one x-axis and two y-axis. That is very important. So this, before going to draw the graph, you have you should mark one x-axis and two y-axis. The x-axis, it is always, it is your field current IF in amps. X-axis, it is always field current in amps. Y-axis, we have two y-axis. So one y-axis, it represents your short circuit current. Let me write here the first y-axis. So this is your short circuit current. Then second y-axis, it is your open circuit voltage, because we have two test data, right? One test data, it is for open circuit test. Another test data, it is your short circuit test, right? So both the graph, we are going to draw it in a single graph sheet. Okay, so what is our test data? So let me write it in the left hand side. So for your field current IF and VOC, then IFC, it is the given data value. I'm writing it here for 10 amps, 20 amps, 30 amps, 40 amps, 50 amps, right? So for 10 amps, your VOC value, what we have calculated, it is 508. Then for 20 amps, it is 953 volts. Then for 30 amps, it is 1270 volts. For 40 amps, 1492 volts. Then for 50 amps, 1651 volts. Then similarly, for short circuit current data also it is given. For 100 amps, 10 amps, it is 200. For 20 amps, it is 400. For 30, 40, 50, no value. So this is our test data. It is given in the problem. Okay, first let me take the x-axis, that is your field current. So what is the value? 10, 20, 30, 40, 50. So how we can take the axis 1 centimeter? 1 centimeter equal to, we can take 1 centimeter equal to 5 amps. For example, 5 amps. Then this point, this is your 10 amps. This point, it is your 15 amps, 20, 25, 30, 35, 40, 45, 50. In this manner, we can have y-axis, x-axis, right? So this is for 1 centimeter, which is equal to, we have taken 1 centimeter equal to 5 amps. So in that manner, we have taken our axis, right? Our x-axis. So that is very important. So while taking the x-axis, all the 50 amps, we should mark it in your x-axis. So we cannot take 1 centimeter to 2.5 amps. So if you take, means, then we cannot plot 50 amps in the x-axis, right? So it is better, we can have 1 centimeter equal to 5 amps, means then all the 50 amps can be plotted here. Then come to the VOC. So VOC, how much? What is the maximum value? It is 1651. So we need to maximum value we should plot here. It is 1651. Okay. So 1 centimeter equal to, we can have 100 volt. Which means we need 16 centimeter, right? 1651 by 100, 16 centimeters. So 16 boxes we need. So we can have 1 centimeter equal to 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1100, 1200, 1300, then 1400, 1500, then the last 1650. Till 1650 we need to mark. So 1700 up to 1700 we can mark. 1600, 1651. Okay, sorry, 1700. So we have taken 1 centimeter wicket is equal to 100 volts. So all the points we can mark it now. Next thing is for short circuit current. So we have only 400 maximum value. It is 400 amps. So we can have 1 centimeter equal to 100 amps. So 100, 200, 300, 400. Or we can have it 50, 100, 200, 300. Like this also we can take it. So for example, you see here instead of 100 we can have 50, 100, 150, better we can have 100. It is easy for us to plot a curve. 100, 200, 300, 400. That is very important. This axis it is your short circuit current axis, and this axis it is your open circuit voltage axis. Okay, so now we can start marking all the points. You look at this. So two characteristics we need to plot. One is open circuit characteristics and another one is short circuit characteristics. Open circuit characteristics is a characteristic curve drawn between IF and VOC. The first point is for 10 amps. For 10 amps, your VOC value it is 508. So 508. So for 10 amps, the first point it is this is your first point 508. For 20 amps, 950. So 953. For 20 amps 953. So this is the point, right? 953. Then for 30 amps 1270. For 30 amps 1270. So this is the point, 1270. Then for 40 amps 1490. 1000 for 40 amps 1490, 92. Okay, so then for 50 amps 1651. So we can mark it for 50 amps 650. So these are all the points. So we can join all the points. We will get your open circuit. We will get from the origin. So this is your open circuit, OCC, open circuit characteristics. Then short circuit characteristics. Similarly, short circuit characteristics for 10 amps 200 volt, 200 amps. For 10 amps, this is the point 200. We can change the color. Better we can mark it in black color. For 10 amps 200 amps. For 10 amps field current, your short circuit current it is 200. This is the first point. Then for 20 amps it is 400. This is your second point. So these 2 points we will get a straight line. With the help of scale also we can draw. This is your short circuit current. See, I repeat, you listen carefully. So the first and foremost step is to plot the open circuit and short circuit characteristics of a given machine. Okay, so the reading everything which is given in the problem. field current versus VOC, you will get OCC core. Field current versus ISC, you will get SSC core. The main challenge here it is that we need to take the axis 1 centimeter. That means the scale. We need to scale the parameter correctly. Then only we can get a curve like this. Okay, so 1 centimeter equal to 5 amps I have taken for field current. For voltage I have taken 1 centimeter equal to 100. So then only we are getting this OCC and the short circuit curve. Next step, what we need to do here it is for EMF method, we need to calculate what is your armature current, right? So armature current, so it is given in the problem. The problem itself, it is given power rating. It is given. So after plotting OCC and SCC curve, then we need to calculate what is a short circuit current, what is the armature current of this machine. Okay, you see here, we know that power rating, the formula to calculate or power rating which is equal to what it is given. It is, we know the formula for, if the power rating is given in VA, √3 VL into IA. Okay, from this your armature current can be calculated 1.1 into 10 to the power 6, right? √3 into VL value, what it is given, VL value 2.2. So 2.2 into 10 to the power 3, since it is kV, so 3. So what you will get, it is IA equal to 288.6 amps. So this is the armature current, we get it. Okay, then from the graph, what is the objective? Why do we need a graph for EMF method? Is to calculate the synchronous impedance. So synchronous impedance from the graph, right? So that is our objective. If anything, if we are doing it, there definitely there should be an objective, right? So why should we need to plot the OCC and SCC graph? Is to calculate the synchronous impedance. The formula of synchronous impedance is Z test, which is equal to VOC by ISC for the same field current. IF, it should be a same value. Okay, for the same field current, VOC by ISC, that is the value of your synchronous impedance. Okay, you see here, what we should do is first the armature current, what we have got it here is 288. So 288, in the sense we will get a point here. Okay, this is your 288 point. So this 288 point, I just to zoom it out. Okay, so you see here, this is 300, 200, 250. So 288, we will get the point here. You project, you mark this 288 at your short circuit, right? So this is your IA value. This is your IA value, and that value you just extend it, you corresponding IF value, the corresponding field current. Okay, the same point we need to project it to the open circuit curve. And a straight line, then it will be better, right? we will get, we just, we will get this point. So this is your VOC. Probably it is 750, 775, right? 775 volt. So that is your VOC. So I repeat, from the short circuit current characteristics, you mark IA, that is 288.6 amps, right? So 288, around 288. So that you extend that 288 value to your short circuit current, then mark the corresponding field current value. This for the same field current corresponding VOC value you need to calculate. So we will get this point. So this is your VOC. VOC, it is 775 volts. So this is that's all. That's all about. That's all we need to calculate it from the graph. Okay. So with the main objective, we need to calculate what is synchronous impedance for the given problem. You see I'm substituting all the values. Z test, which is equal to 7 VOC value, how much? 775 divided by 288.6, right? So for the same IF value, what you will get here, it is 775 plus, sorry, divided by 288.6, we will get 2.6268, 2.68 ohm. That's all. So synchronous impedance value, now it is we calculated from the graph. That's all about EMF method. So why we know that another name of EMF method is synchronous impedance method. From the OCC and short circuit characteristics, we are calculating the synchronous impedance value. That is why it is called synchronous impedance method. So 2.68. So that's all. Then we'll start solving the problem. So as ZS value, it is calculated from the graph. The only thing what we should do is we need to calculate what is ZS. Now with the help of formula, we can calculate regulation value as well as your E phase value. Okay, you see here from the graph, what we have got it ZS, which is equal to 2.68 ohm. Okay, RA value already it is given in the problem. It is 0.22 ohm. From this, zeta excess value can be calculated. We know that root of zeta square minus RA square. So what we will get here, it is 2.68 square minus 0.22 the whole square. You will get your excess. What is excess? What is the excess value? 2.68 square minus 0.22 square root. Excess value, it is 2.67 ohm. Okay. Then, so our primary objective, which is to calculate the voltage regulation. Voltage regulation, percentage voltage regulation. The formula, it is E phase minus V phase by E phase minus V phase by V phase into 100. So this is the formula to calculate voltage regulation. So for this V phase value is given in the problem. What is that? Find our VL value, how much? VL value for this problem, VL equal to, given in the problem, it is 2.2 into 10 to the power 3 volts. From this V phase value, we can calculate VL by root 3. So 2.2 into 10 to the power 3 divided by root 3. So we will get V phase value as 2.2 divided by root 3. So 1.27. So 1270 0.1 volt. So V phase value it is given in the problem. Now we want to calculate what is E phase. Okay, so that is very important. So we know the formula to calculate E phase. This formula, everything it is available in your formula sheet. Already we have derived this formula. E phase, which is equal to root of V phase cos pi plus IA RA the whole square plus V phase sin phi plus or minus IA XS the whole square. So this is a formula. So plus for lagging power factor, minus is for leading power factor. Minus is for leading power factor. From this formula, in this problem, what they have given, they asked us to calculate for 0.8 power factor lagging. So plus only we are going to take. Okay. So we can substitute all the values. We will get what is E phase. You see here. So don't make any mistake while calculating, while typing the values in calculator. So since it is a lengthy expression, carefully we need to calculate. V phase, what is V phase? 1270.1 into cos pi value, it is 0.8. Okay. Plus, what is your IA? IA value, it is 288.6 into, what is your RA? RA value is 0.22 the whole square plus V phase. No, directly we'll write V phase value 1270.1 into sin phi. So cos phi, if it is 0.8 means sin phi it is 0.6. Sin in cos inverse of 0.8, 36.86. Sin 36.86, you will get 0.6 sin pi plus, since we are calculating it for lagging power factor, so we should substitute plus IA 288.6 into excess. What is excess? 2.67. Okay, the whole square. So this lengthy expression we need to type it in your calculator. So please have 2 to 3 steps. Directly don't produce the result within one step. So we need to have 1 or 2 steps. First you calculate 1270 into 0.8. What is the value? Then this value. Then finally you try to do it. If you do it in a single step, definitely you will commit mistake, right? So 1270.1 into 0.8, we will get plus 288.6 into 0.22 whole square. So this value 116547.5.7. So this value I have calculated plus then this value 12701.70.1 into 0.6 plus 288.6 into 2.67 square 2348930.19. So root, so plus 1165475.7 root. So you will get your E phase value as E phase, which is equal to, this is a value 1874.6 volts. This is the value of your E phase. Okay, now we can calculate what is our percentage regulation. Percentage voltage regulation. What is the formula? E phase minus V phase by V phase into 100. So 1874.6 minus 1270.1 divided by 0.1 divided by 18. That's all. We have only one more step. So 1874, sorry, V phase, right? So 1270.1 into 100. And this is a formula to calculate V phase, right? So what is our, we are getting it from the formula. We are voltage regulation is equal to E phase minus V phase by V phase into 100. So in that formula, I am applying it here. So your percentage voltage regulation, what we will get here, it is 1874.6 minus 1270.1 divided by 1270. The final value, it is into 100, 47.5 47.5%. That is the value we obtained it from this. So this is a method. This is a procedure how to calculate voltage regulation using EMF method. Okay. So I repeat, you just listen. So the problem, you read the problem carefully. You read the problem carefully. The first thing is, so see here, open circuit test data, short circuit test data, it is given. So that the short circuit test data, it is current versus IF, open circuit test data, voltage versus IF, right? But before going to draw the graph, first you convert the line voltage into phase voltage. So 0.88 kilovolt. So kilovolt into 10 to the power 3 divided by root 3 508. Similarly, you do this step for further readings. So you will get open circuit test data and short circuit test data. Then plot the graph, right? So we have we have drawn the graph. We have plot the characteristics, OCC characteristics and short circuit characteristics, right? You look at the graph. This is a graph we obtained it for this problem. You see here, open circuit test data and short circuit test data, IF versus VOC, you will get OCC data, OCC characteristics. IF versus ESC, you will get SCC characteristics. Then the only thing what we need to calculate it from the graph here, it is ZS. That is why it is called synchronous impedance method. ZS, how will you calculate the ZS method? VOC by ISC into for the same value of IF. So you mark IA and extend that IA to ISC, you will get the point here. Then mark the corresponding IF. Extend this same point to your OCC curve. Then you will get, then that point you extend it to VOC curve, VOC axis. Then you will get your VOC value. VOC value, it is 775. So 775 by 288, 2.68. So that's all. So the only thing what we are calculating it from ZS is 2.68 ohm, right? Then with the help of formula, V phase, which is equal to root of V phase cos phi plus IARA the whole square plus V phase sin pi plus or minus IA express the whole square. So with the help of that formula, you can calculate okay. So the help of that formula, you can calculate what is your E phase. So E phase for this problem, what we have received the formula value is 1874. Then substitute that value in your regulation formula, you will get 47.5. So since if you are doing it in your class note, so you will get an actual value. Maybe I'm doing it in online, I may get a different value, right? So if you are, if as a student, if you practice it in your tutorial note, you will get an absolute value. Maybe The 47.5, it is little bit higher value. So definitely, because I am plotting the graph in your online, right? So if you are doing it in your class note, you will get an accurate value, maybe some 30 percentage or some 25 percentage, like that you will get it. Okay, so that's all about EMF method. So next class we will see EMF method. Okay, thank you.